Hello everyone, my name is Blaha Gregory Correia dos Santos Goussain from São Paulo State University, UNESP. It is a pleasure to present our research titled Lean Six Sigma-Based Optimization of Barley Waste Management, Mapping Root Causes and Structured Solutions for Continuous Improvement. This work was developed in collaboration with the University of São Paulo and examines how Lean Six Sigma can support sustainable, data-driven waste management practices in the food and beverage sector. Over the next 12 minutes, I will guide you through the motivation, methodology, process mapping, root cause analysis, structured interventions, and the measurable results of this study. Breweries generate large volumes of barley residues, commonly known as brewer's spent grain. If waste is not handled properly, several operational challenges emerge: accumulation of residues and obstruction of internal workflows, increased operational and disposal costs, potential environmental non-compliance, reduced productivity due to interruptions. Lean Six Sigma offers a structured and data-driven approach to identify inefficiencies, reduce waste, and support circular economy strategies. This motivated our investigation into applying DMAIC to optimize barley waste management in an industrial setting. The principal objective of this study was to apply Lean Six Sigma to a Brazilian food and beverage facility to improve barley residue management. 3 goals guided the project. 1. Map the process to identify where inefficiencies originate. 2. Diagnose root causes using structured analysis tools. 3. Develop and validate improvements that enhance sustainability, operational efficiency, and data traceability. Our aim was to combine qualitative insights with quantitative data to produce a replicable model for continuous improvement. Barley waste has high potential value in food, bioenergy, fermentation, and agricultural applications. However, major challenges include limited enzymatic conversion efficiency, storage instability, and logistical constraints. Studies show that Lean Six Sigma improves operational performance, reduces waste, and enhances sustainability outcomes in breweries and related industries. These insights supported the design of our intervention and highlighted the importance of integrating LSS with environmental objectives. The case study took place in a large-scale malt and barley processing facility. Through interviews, observations, and workflow assessments, we identified key issues affecting waste handling: inefficient residue segregation, lack of standardized operating procedures, bottlenecks in internal transport, uncontrolled and disorganized storage areas. Understanding the operational environment allowed us to pinpoint where Lean Six Sigma could generate the greatest impact. This slide summarizes the main stages of beer production: milling, mashing, fermentation, filtration, packaging, distribution. The largest generation of barley waste occurs between the mashing and separation stages, where solid residues are removed from the wort. Mapping these stages was fundamental for detecting waste hotspots and quantifying opportunities for improvement. We structured the entire project using the DMAIC cycle: define, problem scoping, stakeholder interviews, and initial process mapping; measure, quantification of waste volumes, analysis of SOPs, and time study observations; analyze, root cause diagnosis using Ishikawa diagrams and Pareto charts; improve, implementation of layout redesign, SOP development, employee training, and 5W2H-based action planning; control, establishment of KPIs, visual management systems, and digital data collection tools. This methodology ensured rigor, replicability, and alignment with continuous improvement best practices. Data collection took place between February and September 2024. Quantitative data included daily residue generation, disposal rates, process times. Qualitative data included observations of equipment and storage areas, interviews with operators and supervisors, review of existing routines and SOPs. Tools used included SIPOC diagrams, Ishikawa diagrams, Pareto analysis, and structured 5W2H planning. Key equipment involved in residue formation includes the roller mill during milling, stainless steel boilers during mashing, temperature-controlled mashing tanks, decanting equipment where solid residues form. Understanding how each stage contributes to residue production allowed us to map inefficiencies throughout the process chain. The define and measure phases revealed several critical issues. Absence of residue monitoring systems, no classification for different waste types, workflow disruptions caused by poor transport flow, lack of standardized segregation procedures. Approximately 65% of waste handling problems stemmed from uncontrolled storage, inadequate sorting, and inefficiencies in internal movement. Communication gaps further compromised traceability and sustainability indicators. Root causes were categorized using the 6M framework: manpower, method, machine, material, measurement, and environment. The major inefficiencies included insufficient operator training, lack of standardized cleaning protocols, poorly designed layout and flow, no KPI monitoring to support decision-making. Pareto analysis showed that the top 3 causes accounted for over 80% of waste issues, confirming where improvement efforts should be concentrated. Improvement actions were structured using the 5W2H method. Key interventions included development of SOPs for residue segregation, redesign of internal logistics routes and collection points, implementation of a digital residue tracking form, targeted employee training on sustainable practices, scheduled audits, and clear accountability mechanisms. These interventions resulted in a 32% reduction in total waste generation, along with improved data accuracy and operational stability. As a result of process standardization and improved flow, the facility reported an increase in bottled beer volume. The logic is straightforward: less waste, fewer interruptions, more stable production processes. The improvements therefore impacted not only environmental performance, but also productivity and operational continuity. To sustain gains over time, the control phase introduced visual control boards, digital dashboards, standardized reporting templates, monthly KPI monitoring. Together, these tools strengthened the culture of continuous improvement and improved cross-functional collaboration. This study demonstrates that Lean Six Sigma can simultaneously support operational efficiency and environmental sustainability. Waste reduction aligns with circular economy opportunities, such as reuse of barley waste in agricultural and fermentation applications. Digital tools, such as dashboards and tracking forms, improve traceability, data quality, and decision-making. The results align with international research showing the benefits of LSS integration with sustainability practices. From a managerial perspective, standardized workflows reduce variability and enhance reliability. Digital monitoring enables preventive rather than reactive decisions. Improved waste management supports regulatory compliance and resource efficiency. Leaders gain greater visibility into operations, enabling more consistent strategic decision-making. In conclusion, the DMAKE methodology provided a replicable model for optimizing barley waste management. We achieved a 32% reduction in waste, stronger process control, enhanced data traceability, and improved production stability. By integrating Lean Six Sigma with sustainability principles, the study demonstrates how operational excellence and environmental responsibility can reinforce each other. Future research opportunities include incorporating digital twins and AI-based predictive analytics, exploring advanced reuse applications for barley waste, such as fermentation and biomaterials, expanding LSS to other waste streams or brewery units, integrating Industry 5.0 principles to enhance human automation synergy. These directions can further strengthen circular economy outcomes and operational intelligence. Thank you very much for your attention. I will be happy to answer any questions or comments you may have. If you would like to contact me, please write to blaha.goussain@unesp.br.